All right, we are back continuing with the graphs of sine and cosine. So one thing that can happen to the graphs of sine and cosine is a phase shift. So we didn't talk about this in the first part of the notes, but a phase shift is just a horizontal translation. So the vertical translation would move the graph up or down. You would see a plus k or even like a minus k at the end. But the phase shift is what we're going to talk about today, and that's when you move left or right, and that depends on the sign of h. In the function, you'll see it's x minus h, so it is the opposite of what you see, and we'll look at that in the first example. Okay, so h is what is going to indicate your phase shift here. So depending on what your given equation is, you're going to use either the sine or the cosine as the guide. And then it says to identify the x-intercepts and identify the phase shift. If you look in your textbook, you'll see that they have a 5-step pattern that they lay out. So I just kept that consistent with what the textbook did. The first thing you'll want to do is identify the amplitude and the period. So remember, the amplitude is what's multiplied in front. If you can't see anything, that means the amplitude is 1. And then the period is found by doing 2 pi over your value of b. Okay, so then your value of b is what is in front of x. In this case, you don't see anything in front of x, which means that you would do 2 pi over 1, which is just going to be 2 pi. So our period for this graph here is going to be 2 pi, and the amplitude is 1. All right, now we're going to identify the phase shift. So in this case, your h is going to be the pi. Again, remember, it's the minus the value, so we have minus the value. So because our h value is pi, we know that the phase shift is going to be pi radians to the right. Okay, and that's because the pi value is positive. So it is just the opposite of what you see here, just like what we studied earlier in the year with our horizontal shifts. Now, when you have a phase shift, all of the x-intercepts, the max value, the min value, all of those are shifted pi units to the right. Okay, so we're going to be shifting all of those. They do say to identify the x-intercepts. Really, you can wait and do this till after you graph. Like I said, this is how the book shows you. You can look and see what your positive x-intercept is on your cosine graph. So if you are looking at the graph of cosine, which I'm going to show you here, this is your graph of cosine. Remember, at 0 we're at 1, and then this is at pi over 2, at pi, 3 pi over 2, 2 pi. What's happening now is all of these are getting shifted over pi units. So if the first one occurs at pi over 2, okay, what you could do is you could just add the pi to that to get your value. But we're going to see that all of these are actually moving over pi units, and because these occur pi units apart, we are going to find all of them are going to be plus pi n. Okay, so I think it'll be easier for you guys to go and graph that. And that's fine. I know that some of this has been challenging for you, and you might feel more confident looking at your graphing calculator. So again, make sure that your mode is in radians, and then we can graph the cosine. This is x minus, and then you're going to use your pi key. Okay, and then our window, a good one for the x is just doing negative 2 pi to 2 pi. and then going by pi over 2. And then we'll switch this. Our amplitude is 1, so it's not going to be going past that. So we could do -2 to 2, go by 1s. Okay, so if you don't put your mode in radians, this is what you might see. Okay, so we do have to go and make sure that we're in radian mode. All right, now I can graph it again, and I can see my curve. Okay, you could also find your zeros, so you could use your calculator to find your zeros to find the x-intercept. Okay, and it's asking you left bound and then right bound to find the 0. Okay, now this is 1.57, but remember we're going to put it in radians. So 1.57 is at pi over 2, okay, because we went by pi over 2. So we can use that. We're also going to be graphing this. So if this occurs at pi over 2, and then again, you can see on your original graph, the x-intercepts occur every pi units, right? Because this is pi over 2. So this is half of a pi here, half of a pi here, a full pi is happening in between. So that length is pi. This length is pi. This length is pi. So the way that we show that these occur every pi units is we would write pi over 2 plus, they say n pi, or you can say pi times n. Okay, and that is where n is an integer. Okay, and the reason why you are using the integer is because this graph is going to keep going forever, so you want to make sure that you account for every x-intercept. In their step 4, they tell you to identify the max and the min values. Like I said, you can use your graphing calculator to help you with that. They're asking you where they occur at, so we can see that the max, if this is at pi over 2, right? So I have pi over 2, this is pi, this is 3 pi over 2. The max happens at pi. So the maxima occur at pi, and then they occur every period. So it'll be plus 2 pi n. Okay, and again, that's because your 2 pi is your period. So whatever your period length is, it would be that multiplied by n. Okay, and then the value is going to be 1. So that is the maximum value, or the y-coordinate. And the pi is going to be your x-coordinate. So we, again, because of our amplitude, we know that the minimum value is going to be -1. And now we can look and see where the minima occur, and we can see it's right here at 0. So we could do 0 plus 2 pi n, which really 0 plus 2 pi n is the same thing as 2 pi n. So you could say 2 pi n, or if you were looking that they occur here at the 2 pi, you could say 2 pi plus 2 pi n. Okay, and again, that 2 pi n is just a full rotation. So it says graph using all the information about the function and your graphing calculator. Label the 5 points in the table, and then also be sure to label your graph. You can go ahead and you can use your table like I showed you in the original for how you can get your points with your table set. So this is 0, pi over 2, pi, so on and so forth. That's going to give you a nice graph. I'm also just going to show you how you can take the values of the original and then transform them. So you have x, the cosine of x, and then what we're going to graph is the cosine of x minus pi. So we're just going to be moving that over pi units to the right. Okay, so if we took 0, pi over 2, pi, 3 pi over 2, and then 2 pi. On our original graph for cosine, we were at 1. And again, remember, I'm just getting this from those 5 special points that we talked about. Here, here, and here. So we start at 1, we end at 1. Okay, and then here we're at pi over 2. And at pi over 2, we were at 0. At 3 pi over 2, we were at 0. At pi, we were at -1. Now, for the cosine of x minus pi, okay, when we're doing this one, all we're doing is we're taking the x's and we're moving them over. So I'm just going to write these as points. So in the cosine of x, your point is 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. For this one, if we're moving them over pi units, which again, this is pi to the right, then you're going to be adding pi. So now your point here is going to be at pi, and then it's still at 1 because it's only horizontally. If you add pi to pi over 2, you get 3 pi over 2. So you're at 3 pi over 2, 0. If you add pi to pi, you get 2 pi. And then you're still at -1. Okay, and then that's going to continue. These you'll see are going to be off our graph because these are just going to go to 2 pi. So we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so at 2 pi, we are at -1. And I'm going to go by halves. Okay, so at 2 pi, I am at -1. At 3 pi over 2, I am at 0. At pi, I am at 1. And now I'm going to have to go back down. So at pi over 2, I'm going to be at 0. And then because my period is 2 pi, I have to start and end at the same place. And I'm just going to put my curve there, and then that pattern is going to continue. So at -pi over 2, I'm at 0. And again, this is also something that you can see on your graphing calculator. Okay, at 0, I'm at -1. At -pi over 2, I'm at 0. At -pi, I'm going to be at 1. And then I'm going to be at 0. And at -2 pi, I'm going to be at -1. And then we're just connecting these with a curve. Okay, and then that is your graph of the function. Okay, and that is it for 11.1, and then we're going to do 11.2 as well.